Hi, in this video I will show you the amazing power of mathematical induction. This is a technique for proving theorems that say that all natural numbers have a certain property, say p. We can also express the theorem in the form, for all natural numbers n, p of n is true. Then we use the predicate p of n as a shorthand for the expression that the number n has property p. So what might such a property be? Let us look at some natural numbers. The first 5 are shown here on this slide. For each value of n, we first look at the sum of all the numbers from 0 to n. We will write this sum using the capital sigma notation, which is read as the summation as I goes from 0 to n of whatever is written after the big sigma, which is in this case just I itself. So if n is 0, then the sum as I goes from 0 to 0 of I itself is 0. For each next value of n, we find the sum by adding that value of n to the previous sum. So when n is 1, we add 1 to 0, and we find that the sum is 1. When n is 2, the sum becomes 3. For n equal to 3 and 4, we find that the sum becomes 6 and 10. Now this is very interesting, but we don't yet see a property of these numbers. Let's look at a final column in which we evaluate for each value of n the product of n and the number after it, n plus 1, divided by 2. For n equal to 0, this is 0 times 1 divided by 2, which is 0. For n equal to 1, this evaluates to 2 divided by 2, which is 1. For n equal to 2, 3, and 4, the result is 3, 6, and 10. Now we do have a property, namely this. For each of these 5 natural numbers, the value in the second column is equal to the value in the third column. And in fact, all natural numbers have this property. And this is a result we can prove with mathematical induction. For all natural numbers greater than or equal to 0, the sum of all the numbers from 0 to n is equal to n times n plus 1 divided by 2. So how does mathematical induction work? Well, imagine that every number is represented by a domino standing on its side. For a number k, we will interpret the fact that domino k falls over as a proof that the number k has property p. So what do we have to do to show that all the numbers have property p? We only have to knock over all the dominoes. In a proof by mathematical induction, we do this in 2 steps. The first step is to knock over the first domino. In the second step, we have to show that every domino that falls knocks over the next domino. And if we manage that, then we are guaranteed that eventually all the dominoes will fall, and this is equivalent to a proof that all natural numbers have property p.
Nou, thank you so much.